So here's the answer to question 3 part B 2010 paper. So this is the force diagram for the 2m mass. But what's of more interest is when we resolve these into the two directions. So it's really this diagram that would be helpful to us. So that's 2mg cos 45 and 2mg sin 45. Then this is the force diagram for the mass m object, and we need to resolve this as well. And we have mg cos 45 and mg sin 45 as well. And then this is the force diagram for the 4m mass, and we need to resolve these. So we have or cos 45 or sin 45, s cos 45 and s sin 45. And the t and the 4mg is not very important for this problem. So there's three resolved diagrams that we'll need for this: the 2m, the m and the 4m. Then we look at the acceleration picture. So we have acceleration f and a, but again we need this resolved. So we have f cos 45 and f sin 45. Now with all the diagrams we can make the equations. So looking at the first diagram, we have or minus 2mg over root 2, so that's the force, and that's to equal ma, which in this case will be minus 2mf over root 2. On the second diagram, we have s minus mg over root 2, and that's to equal minus mf over root 2. So it's the same, f equals ma. And then finally, we have or over root 2 plus s over root 2 equals 4mf. Now, we could make another equation involving A, looking at the forces parallel to the wedge surface, but it's not necessary for this particular problem because we're only asked for F, and you'll notice that we'll have three equations now with or, S and F in them, so we actually have enough information here. And as we saw today, we only get one more equation from looking in the direction parallel to the wedge surface, so this will give us the fourth equation and introduce the fourth unknown A, but not necessary for this problem. So what we do next is just write each three equations in the order or, S and F. So you can see in the first one we have one or, no s's, and we have an f term on the right which we bring over to the left and bring the constant over to the right. So just rearrange them in the normal order, putting what we want last. We'll have 1 or plus 0s plus 2m over root 2f equals 2mg over root 2. We do the same for the second equation, so it's or sf equals constant, and we do the same for the final equation, so it's or sf equals constant. Putting this in a array form, and we have this problem we need to solve. Now, in the last line, what I'll do is I'll multiply across by root 2, so you can see from going from here to here, I just multiply everything on the last line by root 2. Now I need to get all these the same, 1, 1 and 1. There's nothing I can multiply the second row by to make this 0 become a 1, so what I'll do is I'll add the top row into the second row, so drop all these numbers in to the second row. So I'll get this now. So if you can see, this 1 drops down, this 0 drops down, this 2m over root 2 drops down, and this 2mg over root 2 drops down. So I have like terms here that I can add and like terms here that I can add, so I just add them together, and now I get this problem. Now I see I have all the ones here. So I run the last equation through everything, the first minus the last, the second minus the last, etc. So this line, first line minus the last, and then the second line minus the last. So I'm left with this now. So there's all zeros in the last line, because it's the last line minus the last line. So I can drop those, and then there's zeros here. I can drop them as well. So now my problem has been reduced. Again, there's a zero here, so I'll need to add in the top line onto the second line, and I do that. And you can see now that I have minus 1 here, minus 1 here. But I also have like terms I can add together. You see here I have 4 root 2m and 4 root 2m, 3m over root 2 and 2m over root 2, etc. So adding all the like terms together, and I'm left with this. Now I can do the top, the first one minus the last, and the last minus the last. So I'm left with this. All the zeros can be dropped, and I have like terms that I can add together. So adding the like terms together, and I'm left with this. And dropping the zeros. Now, I'll divide everything by minus 1, or multiply everything by minus 1, so all the signs are gone. And now I'll divide everything by 4 root 2m plus 3m over root 2, and I'm left with this. Cancelling all the m's, and I'm left with this. I'm putting the term on the right in my calculator, and I'm left with this. And returning this back to equation form, I have 1f equals 2.6727, etc. So I have my answer. F is approximately 2.67 meters per second squared.